So, internal energy is the type of energy stored in any objects made of particles. So, it's the energy due to the particles. It's called internal because basically it's within stuff. Okay, so what we have is, let's say we draw a few particles. Okay, so we've got some here and they're vibrating. So, because they're vibrating, they have kinetic energy. Kinetic energy forms part of the internal energy. But also there are bonds between each of the particles, as you can see here. So we've got bonds and we've got kinetic energy. Adding those types of energy together, okay, or the energy due to bonds, which is the potential energy, totals are internal energy. So we say that internal energy is the potential energy from bonds between the particles and the kinetic energy of the particles, so how much they vibrate. So if we were to increase the temperature of something, the particles would vibrate more, so their kinetic energy would increase, and as a result, because their kinetic energy increases, their internal energy, okay, increases. I can't even spell. So a good definition would be internal energy is the total kinetic energy and potential energy of all the particles that make up a substance. And that's all internal energy is that. Now let's look at solids, liquids and gases and their properties. Okay, so let's quickly look at what happens between states. So if we go to a solid to a liquid, we call that melting. If we go from a liquid to a solid, we call that freezing. If we go from a gas, so from a liquid to a gas, okay, we call that evaporation, or we could call it boiling if we wanted to. And if we go the other way, from gas to liquid, we call that condensation. And in certain circumstances, we can go from a solid straight to a gas, and that's called sublimation. You need to know all these. You should know all those anyway because of just normal everyday life. So here are the properties. So for a solid, the particles are all lined up like soldiers, okay, and all touching like so, okay, and we're going to discuss why that is soon. But remember, they must always be touching and they must always be lined up like that, okay. And then liquids, most of them are touching but they're not lined up, and there are gaps every now and then. They should still be touching in places like I'm doing here, but they're all jumbled up, and there are a few gaps but mostly touching, and that's really important, okay. And then gases, they are spread out, none of them are touching, okay, and there doesn't have to be many of them like that, okay. Now let's look at why that is. So this is how we describe it. We say for solids, the particles are arranged regularly, which means they're arranged in straight lines. Particles arranged regularly. So if we get a question, which we will do, we can draw on that, okay, to help us. And we can say they vibrate in fixed positions. So they move, but they don't move off the spot. So they vibrate in fixed positions. That is for solid. And then we say they have a fixed shape. Solid things generally don't change shape on their own, so we say have a fixed shape. Okay, and then have strong force of attraction. That's why they all stay together. Okay, traction means coming together, so strong forces of attraction, holding them together. Okay, and then we can say particles have the lowest kinetic and internal energy. Okay, so we can just say lowest internal energy. Now, gases are pretty much the opposite to solids, and then liquids are in between. Okay, so there are large gaps between particles. Okay, so we can say large gaps between particles. Obviously, solids have no gaps between the particles. All right, they are arranged in an irregular way, so we can say irregular arrangement. And then they take the shape of the container. That's often what you can say. So you were to release gas into a room, it would form the shape of the room. It would spread out. Take the shape of the container. They have very weak force attraction. That's why they're able to move around. They don't stay together, the particles, with weak forces of attraction. Particles have high kinetic and internal energy, so we can say high internal energy. And then finally, okay, they move random, so we can say random movement. Now, for liquids and gases are very similar, except the only difference is they have small gaps between. Small gaps, so we can put small gaps there. Okay, they have weak force of attraction, like gases. And they are arranged irregular, so we can say irregular arrangement. And then finally, they also take the shape of their container. Take shape of container. Now you will need to remember these properties because it will really help you with some questions, as we're going to do in the second video for this section. Okay, so we're going to use this for answering the remainder of the questions.